When sizing conductors for a fire pump, it is crucial to understand the relevant electrical codes and standards to ensure proper protection and functionality. The question at hand concerns whether the conductors supplying a fire pump need to be sized based on the locked rotor amps, abbreviated LRA, or if they can be sized based on the reduced voltage starting amps, abbreviated RLA. The definitive answer is that the conductors must be sized to accommodate the locked rotor amps of the fire pump motor. This requirement stems from the need to ensure that the conductors can safely handle the high inrush current that occurs when the motor starts. The locked rotor amps refers to the current drawn by the motor when it is initially energized and the rotor is stationary. This current can be significantly higher, often 6 to 8 times, than the motor's full load amps rating. If the conductors are not sized to handle this inrush current, they could overheat, leading to insulation damage, premature failure, or even a fire hazard. Electrical codes, such as the National Electrical Code, abbreviated NEC, provide specific guidelines for sizing conductors for motor applications, including fire pumps. These guidelines take into account the locked rotor amps, as well as other factors such as the motor's full load amps, the ambient temperature, and the type of insulation used for the conductors. When sizing conductors for a fire pump, it is essential to refer to the specific requirements outlined in the NEC and other applicable standards. These requirements may vary depending on the voltage of the system, the type of motor used, and other factors. In general, the conductors must have an ampacity rating that is at least equal to the motor's locked rotor amps. In some cases, it may be necessary to increase the conductor size to account for voltage drop or other considerations. Voltage drop refers to the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can negatively impact the performance of the fire pump motor, causing it to run inefficiently or even stall. To minimize voltage drop, it is important to select conductors that are large enough to carry the required current without significant voltage loss. In addition to sizing the conductors for the locked rotor amps, it is also important to select appropriate overcurrent protection devices to protect the conductors and the motor from overload and short-circuit conditions. Overcurrent protection devices, such as fuses or circuit breakers, are designed to interrupt the flow of current in the event of an overcurrent or short circuit. The overcurrent protection devices must be sized to protect the conductors from damage due to excessive current, while also allowing the motor to start and run normally. The NEC provides specific guidelines for sizing overcurrent protection devices for motor applications, including fire pumps. These guidelines take into account the motor's full load amps, the locked rotor amps, and the type of overcurrent protection device used. When selecting overcurrent protection devices for a fire pump, it is important to consider the specific characteristics of the motor and the electrical system. The overcurrent protection devices must be able to withstand the high inrush current that occurs when the motor starts, while also providing adequate protection against overload and short-circuit conditions. It is also important to ensure that the overcurrent protection devices are properly coordinated with the other protective devices in the electrical system to prevent nuisance tripping and ensure reliable operation. In summary, when sizing conductors for a fire pump, it is essential to size them for the locked rotor amps to ensure that they can safely handle the high inrush current that occurs when the motor starts. It is also important to select appropriate overcurrent protection devices to protect the conductors and the motor from overload and short-circuit conditions. By following the guidelines outlined in the NEC and other applicable standards, one can ensure that the fire pump is properly protected and will operate reliably in the event of a fire. Consider a scenario where a fire pump motor has a full load amps rating of 100 amps and a locked rotor amps rating of 600 amps. According to the NEC, the conductors supplying the motor must have an ampacity rating that is at least equal to the motor's locked rotor amps. In this case, the conductors would need to have an ampacity rating of at least 600 amps. In addition to sizing the conductors for the locked rotor amps, it is also important to select appropriate overcurrent protection devices to protect the conductors and the motor from overload and short-circuit conditions. The NEC provides specific guidelines for sizing overcurrent protection devices for motor applications, including fire pumps. These guidelines take into account the motor's full load amps, the locked rotor amps, and the type of overcurrent protection device used. In this scenario, the overcurrent protection devices would need to be sized to protect the conductors from damage due to excessive current, while also allowing the motor to start and run normally. It is important to consult the NEC and other applicable standards to determine the appropriate size and type of overcurrent protection devices for this specific application. Furthermore, it is important to consider the voltage drop along the conductors. Excessive voltage drop can negatively impact the performance of the fire pump motor, causing it to run inefficiently or even stall. To minimize voltage drop, it is important to select conductors that are large enough to carry the required current without significant voltage loss. The NEC provides guidelines for calculating voltage drop and selecting conductors that are appropriately sized to minimize voltage drop. In addition to the NEC, other standards and regulations may apply to fire pump installations depending on the location and the specific requirements of the authority having jurisdiction. It is important to consult with local authorities and qualified electrical professionals to ensure that the fire pump installation complies with all applicable requirements. Proper conductor sizing and overcurrent protection are critical for ensuring the reliable operation of a fire pump. By following the guidelines outlined in the NEC and other applicable standards, it is possible to ensure that the fire pump is properly protected and will operate reliably in the event of a fire. The NEC Article 695 covers the installation of fire pumps. Section 695.6, Power Wiring, specifically addresses the requirements for sizing conductors for fire pumps. This section mandates that the conductor supplying the fire pump motor must have a rating not less than 125% of the motor's full load current rating, in addition to being sized adequately for the locked rotor current. This ensures that the conductors can handle the continuous load of the fire pump motor during operation. Section 695.6c specifically addresses overcurrent protection. It states that the overcurrent protective devices must be sized to carry the locked rotor current of the fire pump motor indefinitely. This is a critical requirement because fire pumps are expected to operate under potentially extreme conditions and for extended periods. The intent is to prevent nuisance tripping of the overcurrent device during the fire pump's operation. The overcurrent protection is primarily intended to protect the conductors and motor from short circuits and ground faults, not from overload conditions. The sizing for overcurrent protection can be determined using the motor's nameplate data and relevant tables in the NEC, such as those found in Article 430, which covers motors and motor circuits. Specifically, Table 430.52 provides guidance on the maximum rating or setting for motor branch circuit, short circuit, and ground fault protective devices. However, it's essential to comply with the specific allowances and restrictions provided in Article 695 for fire pump applications, which may override some of the general motor circuit protection rules. It's important to distinguish between locked rotor amps and reduced voltage starter amps. Locked rotor amps, abbreviated LRA, is the current drawn by the motor when it is initially energized and the rotor is stationary. Reduced voltage starting amps, abbreviated RLA, refers to the current drawn during starting when a reduced voltage starting method is employed, such as using an auto transformer or a part winding starter. While reduced voltage starting methods can lower the inrush current, the conductors and overcurrent protection must still be capable of handling the full locked rotor current if the motor were to start under full voltage conditions. Furthermore, the conductors must be sized to account for voltage drop. Voltage drop can significantly affect the performance of the fire pump motor, leading to reduced efficiency and potential motor damage. The NEC recommends limiting voltage drop to a maximum of 5% from the source of power to the motor terminals when the motor is operating at full load. To calculate voltage drop, one needs to consider the conductor length, conductor material, conductor size, and the current flowing through the conductors. Using larger conductors or shortening the conductor length can help reduce voltage drop. In addition to conductor sizing and overcurrent protection, other factors to consider when installing a fire pump include the reliability of the power source, the grounding of the electrical system, and the proper installation of the fire pump controller. Fire pumps are typically supplied by a dedicated power source to ensure reliable operation during a fire. The power source can be a utility feed or an on-site generator. The grounding of the electrical system is critical for safety and to prevent electrical shock hazards. The fire pump controller is responsible for starting and stopping the fire pump motor and for monitoring the system for faults and alarms. The controller must be installed in accordance with the manufacturer's instructions and the requirements of the NEC. Here are some additional points to consider. Firstly, ensure that the fire pump system is inspected and tested regularly to verify its proper operation. Regular maintenance and testing can help identify and address any potential problems before they become critical. Secondly, keep accurate records of all inspections, tests, and maintenance activities. These records can be helpful for troubleshooting problems and for demonstrating compliance with regulatory requirements. Thirdly, provide adequate training to personnel who are responsible for operating and maintaining the fire pump system. Properly trained personnel can help ensure that the system is operated safely and effectively. Fourthly, when working on fire pump electrical systems, always follow safe electrical work practices, including wearing appropriate personal protective equipment, abbreviated PPE, and de-energizing circuits before working on them. Fifthly, consult with qualified electrical professionals for any questions or concerns about fire pump installations. Electrical professionals have the knowledge and expertise to ensure that fire pump systems are installed and maintained in accordance with all applicable codes and standards. The selection of the correct conductor size and overcurrent protection device is crucial for fire pump installations. The fire pump is an essential component of a building's fire protection system. Its reliable operation is vital to saving lives and protecting property. The NEC provides specific guidance on the installation of fire pumps, including requirements for conductor sizing, overcurrent protection, and other aspects of the electrical system. Section 695.3 of the NEC requires that the fire pump source of power be reliable. This typically involves connecting the fire pump to a separate service or a generator that is dedicated to the fire pump. This ensures that the fire pump will have power even if the main building power is lost. Section 695.4 covers the continuity of the circuits. This section requires that the circuits supplying the fire pump be independent of all other electrical loads. This prevents a fault in another part of the building from affecting the operation of the fire pump. Section 695.5 covers the transfer of power to the fire pump. This section requires that the transfer of power to the fire pump be automatic and that it occur within a specified time frame. This ensures that the fire pump will start quickly in the event of a power loss. Section 695.12d of the NEC covers the protection of the fire pump against damage from voltage transients. This section requires that the fire pump be protected by surge protective devices, SPD, or other means to prevent damage from voltage surges. Section 695.14e of the NEC covers the marking of the fire pump equipment. This section requires that all fire pump equipment be clearly marked with the words fire pump and with the voltage and current ratings of the equipment. This helps to ensure that the equipment is properly identified and that it is not overloaded. It is important to remember that the fire pump is a critical component of a building's fire protection system. Its reliable operation is vital to saving lives and protecting property. By following the requirements of the NEC and other applicable standards, you can help to ensure that the fire pump is properly installed and that it will operate reliably in the event of a fire. Additionally, regular inspections and testing of the fire pump system are essential to verify its proper operation. These inspections and tests should be performed by qualified personnel and should be documented in accordance with applicable codes and standards. Any problems identified during these inspections and tests should be corrected promptly to ensure the continued reliable operation of the fire pump system. Voltage drop is a critical factor to consider when sizing conductors for a fire pump. Excessive voltage drop can reduce the motor's torque and efficiency, leading to poor performance or even failure of the fire pump. The NEC recommends limiting voltage drop to a maximum of 5% from the power source to the motor terminals when the motor is operating at full load. To calculate voltage drop, you need to consider the conductor length, conductor material, conductor size, and the current flowing through the conductors. The formula for calculating voltage drop is voltage drop equals 2 times K times I times D divided by circular miles, where K is the direct current constant, I is the current in amps, D is the one-way distance in feet, and circular miles is the conductor area. You can use this formula to calculate the voltage drop for a given conductor size and load. If the calculated voltage drop exceeds 5%, you need to increase the conductor size to reduce the voltage drop. In addition to voltage drop, you also need to consider the ampacity of the conductors. The ampacity of a conductor is the maximum current that it can carry continuously without overheating. The NEC provides tables that list the ampacity of different types of conductors based on their size, insulation, and installation conditions. You need to select conductors that have an ampacity that is equal to or greater than the motor's full load current plus 25%. This provides a safety margin to account for variations in load and ambient temperature. When selecting overcurrent protection devices for a fire pump, you need to consider both the motor's full load current and its locked rotor current. The overcurrent protection devices must be able to carry the motor's full load current continuously without tripping, but they must also be able to trip quickly in the event of a short circuit or a ground fault. The NEC provides specific guidelines for sizing overcurrent protection devices for motor applications, including fire pumps. These guidelines take into account the motor's full load current, the locked rotor current, and the type of overcurrent protection device used. For fire pumps, the overcurrent protection devices are typically sized to allow the motor to start and run without tripping, but they must still provide adequate protection against short circuits and ground faults. This often involves using fuses or circuit breakers that have a time delay characteristic. The time delay allows the motor to start and run without tripping the overcurrent protection device, but it will still trip quickly in the event of a short circuit or ground fault. It is important to select overcurrent protection devices that are specifically designed for motor applications and that are properly sized for the fire pump motor. It is also important to ensure that the overcurrent protection devices are properly coordinated with the other protective devices in the electrical system to prevent nuisance tripping and ensure reliable operation. Proper conductor sizing and overcurrent protection are critical for ensuring the reliable operation of a fire pump. By following the guidelines outlined in the NEC and other applicable standards, you can help to ensure that the fire pump is properly protected and that it will operate reliably in the event of a fire. In conclusion, fire pump conductor sizing demands careful consideration of locked rotor amps, abbreviated LRA, to ensure safe operation and code compliance.